continuing on. What is negative 4 plus 1, please? Negative 3. Is negative 3 positive or negative? Now here's the part that tricks people, and I'm still going to go to you, Madison, and I apologize. Okay? If you sub negative 4 into 1, is it positive or negative? Well, what's the value here going to be? What's the value here going to be? Always. Well, if I sub x equals 4 into 1, what's the result? 1. Right? It doesn't change. Okay, right? Because there's nothing to sub into. All right? So this is just going to stay positive all the way along. This is the thing that confuses people. If I say I have $1 and you say x equals 5, I say I don't care. I still have $1. Right? So you know what I mean? It's still 1. No matter what x is, the value is always going to be 1. Are we clear on that? I use a joke for that, but that's the thing. This is always going to be positive. So all the way along here, that's positive and that's positive. The reason you might say, Mr. Sadler, why would I include that in there? It's because when I get to example 2 and I have a negative 2 in the numerator instead of a 1, you got to flip it. Are we somewhat following what's happening here so far? A little bit, yes? All right. Now, here's the thing that, oh, sorry, can I ask one?
The numbers don't matter?
No. Because it's just like a group of numbers. That's the thing that's tricky here. If you want to write negative 3, negative 5, that's fine, but we're trying to overall represent if it's positive or negative. That's the thing that's tricky. Now, here's the thing that gets people. So, if you're sitting in the back row and fading out, you've got to fade in right now. These are all going to be multiplied together. If you take a look at your original equation, it was this divided by this divided by this, right? That's how we got our equation. So what I'm going to say is, if I have a positive number divided by a negative number, what's the result? If I have a negative number divided by a negative number, what's the result? So my result here is going to be positive. You have no idea. Ask away if you have no idea. What I just said, I just multiplied top down. Positive times negative is negative, and then negative times negative is positive. Okay? That's all I do is just multiply. That's all I'm doing. Why am I doing it? Good question. It's okay. It's okay. It's okay. I'm actually going to use numbers now. I wasn't going to. Hold on a second. I wasn't going to use numbers. I actually am now. Okay? We started here with a 1 and x minus 1 and x plus 1. We said this was minus 5 now, right? Because we had negative 4 minus 1 is negative 5. We said this is negative 3. Okay? You don't actually need the numbers. We're using the general case over here. I'm just explaining it this way. I'm going to erase this in a sec. 1 divided by negative 5 is then divided by negative 3 is going to be 1 over positive 15. Right? So it's going to be a positive number. That's what I'm trying to say. No matter what number you... Sorry, ask why. All I'm saying is no matter what number you pick for x, guys, can I talk to you, please? That's less than negative 1, you're going to end up with a positive. The denominator is going to be positive.
Okay. So you weren't dividing the second, right?
Well, you're sort of you're dividing it overall. You know what I'm saying? Like these two are multiplied, right? But they're overall divided. Like if you were to do this on your calc, you do 1 divided by 5 equals 1 divided by 3, negative 3 equals. That's what you do. Okay. Stick with me here. Okay. So what I'm saying is overall the denominator. Oh, I'm going to erase that. The numerator is always going to be positive, and that's what I'm saying here. Oops, the numerator is always going to be positive. That's this. The left part of the denominator is negative, and the right part of the denominator is negative. That's all I'm saying with this. So overall, it's going to be positive. All right. Okay, let's keep going here. Okay, this will click. We'll do a few more examples. This will click. The way you graph this is, if the graph has to be, it says it's positive, so the graph has to be above 0 like this. Okay, that's what we're saying. The graph has to exist only from here to here. So what I'm going to do is I'm just going to graph it sort of like this. Okay. So it looks just like the 1 over x stuff on the other side. Okay. So all the values here, please. All the values here are positive. Right? Everything here is above 0. The other thing, if you really want to get technical and actually plot points, if you do something like negative 1.001, that's going to be an enormous number, right? And you could figure that out if you really want to. All right? I'm going to work to the right first, next, and I'm going to go back to the middle. Okay, I'm going to do number 3. So I'm going to choose this over here. I'm picking on Brooke right now. Brooke, I'm choosing x equals 4. What is 4 plus 1, please? 5. Is 5 positive or negative? Good. Brooke, 4 minus 1 is 3 positive or negative? Sorry, I'm just wondering. Okay. So I have a positive numerator and 2 positive denominators. What's the overall result going to be? Positive. Okay, so that's also going to look like this. There are arrows on the ends here. I don't know if you can see those that well. There's going to be arrows everywhere. All right. Curtis, you're ready? Yeah, I'm going to take it out. All right, now for the middle section. Georgie, I'm picking on you. Georgie, what is 0 plus 1, please? What is 1 positive or negative? Georgie, what is 0 minus 1, please? Is negative 1 positive or negative? Negative. Now here is the trickiness, and this is what gets students in a million years to solve this. What's the result going to be for this, positive or negative? Now negative, but Mr. Sadler, there's more positives than negatives. How come it's not positive? Why is it not positive? Because we're multiplying. Remember, you're multiplying. Positive times a negative. Okay, I get asked every year this one. Drives me batty. That's going to be a negative. Now here's the tricky part here too. You've never seen this before. I have to get a graph underneath this line and between here and here. Are there any suggestions for how that would look? It's like a parabola. Okay, it's not quite a parabola. Okay, it's called, because a parabola, if you remember, will go on forever and ever, left and right. Okay, so because it can't, but it's parabola-like. I believe the term is hyperbola, but if I say that and it's wrong, one of the 2 viewers of my videos will correct me and tell me it's not that. Okay, but I believe it's hyperbola is the name of that shape. But it's parabola-like. Okay. Now. Yeah, there are arrows on it. Sorry, those are arrows on it. Oh, there's arrows in all these. Sorry, I've been sloppy. Those are all arrows. Okay, I'm going to try one more of these for you guys to try right now. Okay? Do you guys want me to work with you, or do you want to try it on your own? With me? Okay, one thing I forgot to do was domain and range. Can somebody tell me? Okay, now do not freak out. Everyone always is afraid of domain and range. Georgie, please put your head up. Please stay in the zone here. This is highly important. There are 7 drafts in your final exam. This is one of them. Okay? Okay, let me say that again. I heard what? I don't stutter. There are 7 exams on the 7 drafts in the final exam. This is one of them. Okay, domain and range. Domain and range you can do right away based on your asymptotes. What do the asymptotes say? Can somebody read out the asymptotes for me? X cannot equal 1, X cannot equal negative 1. Guess what my domain is? Domain is all values of x such that x cannot equal 1 and negative 1. That's good enough. Okay. With that hint, can someone be brave to tell me what the range is going to be? Madison, go ahead.
Which range is 0?
Why can't be 0? Okay. Now, there are some people, please don't be anybody in this class, that would like my range to be this. And you don't even write this down, but some people like this. Okay, technically that's right too, but please, don't do this to yourself. Don't do that to yourself. All right, but that is technically right as well. It goes from negative infinity to 0, doesn't hit 0, and then goes from 0 to, it's much easier to write, can't be 0. Right? Okay. Okay, I know this is tricky the first time through. Colton will go through some of these to make sure that it's good. I'm going to hit pause and start to yell here in a second, because my morning class ticks me. All right, can I stop? Stop. Let me